The Chengdu J-20 is widely presented through official channels as a fifth-generation stealth fighter designed to compete with the most advanced combat aircraft globally. However, based on open-source intelligence, aerospace engineering assessments, satellite imagery, and analysis from defense experts, the aircraft falls short of full-spectrum stealth standards across multiple technical dimensions. The design of the J-20 does incorporate some elements that reduce radar cross-section (RCS) particularly from the frontal aspect. These include forward swept air intakes, a chined fuselage, and canted vertical stabilizers, which help deflect radar energy away from its source. The aircraft is also coated with radar-absorbent material (RAM), and its weapon bays are internal to reduce radar reflection. Despite these features, the aircraft's stealth effectiveness is compromised by several major design and engineering factors. The most critical issue is the propulsion system. The vast majority of operational J-20s continue to fly with WS-10C engines or earlier Russian Alabama 31F engines, neither of which are optimized for stealth. These engines generate a large infrared signature, are acoustically loud, and have exposed engine nozzles, all of which contribute to greater visibility on both radar and infrared detection systems, especially from the sides and rear. A genuine stealth aircraft must have a low RCS in all directions and must suppress heat and noise emissions to evade infrared search and track (IRST) systems, but the J-20 does not meet this standard in its current form. There have been ongoing claims in domestic media that the newer WS-15 engine has entered service. However, there is limited visual or technical confirmation that this engine is operational across the broader J-20 fleet. Most evidence indicates that the WS-15 is still in a developmental or prototype testing phase, with very few units possibly equipped for evaluation flights. Until these engines are fully integrated into the fleet with proven reliability and stealth-enhancing features, the aircraft remains dependent on powerplants that limit both its stealth performance and flight envelope. The airframe design also raises concerns. While the forward fuselage has reduced radar reflectivity, the side fuselage and rear section, including the engine exhaust area, show a more conventional configuration. The lack of serrated nozzles, limited shielding of engine hotspots, and use of traditional flight control surfaces all increase radar and thermal signature. Additionally, the aircraft's canards, small forewings mounted near the cockpit, may provide agility, but they also generate radar reflections, further reducing stealth effectiveness, especially when maneuvering. Radar-absorbent materials on the J-20 are another point of concern. Reports from industry insiders and leaked technical literature suggest that the coatings used on the aircraft degrade relatively quickly when exposed to rain, humidity, ultraviolet radiation, and the extreme heat generated during supersonic flight. This degradation significantly increases maintenance demands and reduces the aircraft's low observability lifespan between missions. A high-maintenance stealth platform is less effective in high-tempo or deployed combat scenarios, where constant upkeep may not be feasible. Another limitation is the aircraft's electronics and systems integration. Stealth is not just about radar invisibility, it also depends on having low probability of intercept sensors, secure data links, real-time sensor fusion, electronic countermeasures, and coordinated battlefield networking. While the J-20 is claimed to feature these capabilities, there is no independent verification of consistent performance in large-scale joint exercises or electronic warfare environments. Observers note that much of the Chinese-language media coverage is highly curated, with little transparency regarding real mission data, fail rates, or test results. Additionally, external flight configurations frequently captured in photos and videos, such as external fuel tanks or underwing stores, render the aircraft non-stealthy during such missions. This suggests that the J-20 may not always operate in a stealth configuration, either due to operational requirements or limitations in internal weapons and fuel storage capacity. This compromises the low observability mission profile that a true stealth aircraft is supposed to maintain across all phases of flight. Furthermore, despite claims of widespread deployment, satellite surveillance and regional military observations show that J-20 units are concentrated in select areas with limited operational tempo. There is no confirmed evidence of the aircraft being tested or deployed regularly in contested environments that include advanced enemy air defenses, jamming conditions, or complex multi-domain coordination. Without such testing, the true combat readiness of the platform remains uncertain. The J-20 is an advanced fighter that incorporates some stealth-related technologies but does not currently fulfill the full requirements of a true stealth aircraft. Its partial stealth design, outdated engines, maintenance-heavy coatings, and unproven electronic warfare systems limit its real-world survivability and effectiveness in modern high-threat air combat. While development continues and future versions may address some of these issues, the current operational versions remain closer to a transitional platform rather than a fully stealth-optimized fighter.